Okay. So last time we discussed about electromotive force EMF, right?
Yes.
And we have to discuss a difference between potential difference and EMF, right? So now today we are going to talk about potential difference, and I already told you about that both quantities are in the category of voltage, right? But there is a
Yes.
conceptual difference between these two quantities, right?
Yes.
And for EMF, we discussed that EMF is basically related to the source and a single charge that is going to be driven throughout the circuit, right?
Yes. Yes.
So the amount of energy we require to convert that chemical energy into electrical energy is known as EMF. So potential difference is also a type of a voltage, right? But the difference is that it is a voltage, or we can say that it is also a type of work done on a charge in moving charge through the components, right?
Yes. Yes.
Now there is a difference because number of components, right? Basically, when we are going to use a 9-volt battery, let's suppose there are 3 lamps or 2 lamps, and each lamp is going to be consume 3 volt, right? So we are basically providing 9 volt. One lamp is consuming 3 volts, so it is going to be divide 3 3 3, right?
Yes.
So voltage will be different according to their combination. It depends upon combination. Either they are going to be connected series combination or in parallel
So
combination.
potential difference is like how much energy requires to like work.
Yes,
Maybe with
for component or for a charge to pass through that is specific component, right?
oh,
Or symbol remains same. If we talk about the symbol, so basically symbol for EMF is E, but for potential difference we are going to write V. The symbol is V, and the SI unit remains same. So if we talk about the SI unit, so the SI unit for EMF and potential difference both remain same, that is volts
yes.
V, right? Symbol and SI unit, the symbol of both SI unit and the symbol of quantities are same, right? Both are
Okay.
equal to V. Okay.
Okay.
Any confusion?
No.
Okay. Okay. One more thing. If you want to more specify that what will be the difference between EMF and potential difference. So I'm just writing in two short points to identify the difference, because these are basic definition, and still if you want to differentiate between them, so you use the concept that EMF is a voltage of the source, right? It depends on the
What was the
source.
meaning of voltage again? Maybe.
Basically, in generally, we use a word voltage, right? EMF and potential difference both are the same concept of voltage, but still there is a difference. When we are
No.
talking about the voltage
What was the
of
meaning of
source,
voltage?
what is the meaning of
Voltage.
voltage? Okay, basically in general, if we talk about just a charge is going to be moved from the battery to the circuit, right? So that is the concept of
Yes.
voltage. Voltage means when you are going to transfer charge from high potential to low potential, right?
Oh. Oh.
Because positive is a high potential, because charge always move from positive to negative terminal,
Negative.
right? Just like a
Yes.
normal in daily life, let's suppose if we are having a slope, if we place a ball on the top of the floor or top of the slope, so it will automatically roll down to the lower surface, right? Because we
Yes.
place
Yes.
ball on high potential, and it is a universal law that always every quantity or each quantity will move from high to low point, just like heat, right? So
Yes. Yes.
voltage is basically a difference between voltage, or sorry, between potential, and that is a difference between high potential and low potential, right? And both are
Yes.
voltage. EMF is also a voltage, potential is also a voltage. So
Also
in
voltage.
generally
Okay.
we use word voltage, but specifically when they ask you about EMF, so it means they are concerned about the source. They are only talking about battery. This concept will help you in your A levels, right? Because when you
Yes,
start
yes.
studying in your ALs, so there is a complete separate concept of EMF. So we calculate voltage for batteries, that is known as EMF, voltage for circuit, that is voltage. But in O levels, we only journal solve voltage, V, right?
Yes, yes.
So basically, this is a base concept. And potential difference, I'm writing in short PD. Potential difference is also a voltage throughout the circuit, right?
Yes.
So this is a voltage throughout the circuit. It means we need to count all the voltage related to all the components connected in the circuit. Okay.
Yes, yes.
Any confusion till now?
No, no.
Okay. So these 2 points, these are very short point, but that will give you a clear concept that how these things are different, right? Because by
Okay.
definition, it was still difficult to identify, right? Because there are scientific terms.
Yes, yes.
So at earlier stage, we use these concepts to identify the terms between EMF and potential
So
difference.
EMF is basically like the amount of energy coming from the cell.
Yes, it is completely related to the source, right?
Okay. The other one is around the whole circuit.
Whole, yes. So you need to count the number of components which are connected and how much voltage they are going to be consumed. So that is the difference, right?
Oh,
There
yes.
are multiple definition. You will find multiple definitions in different book on internet, but I found or I write these type of definition because these are the simplest one, right?
Oh,
And I hope you also got the concept, right?
yes, yes, yes.
Okay. Because for O levels, we are not going to solve individual questions of EMF and potential difference, right? But we need
Yes,
to
yes.
know about that there is a difference because in A levels, you are going to solve all the questions, right? So if your base is
Yes.
already strong, so that will help you. Okay. So we discuss about three quantities: current, EMF, potential difference, right? So now we are having an other quantity that is known as resistance, right? Resistance is our new concept. This is an other new physical quantity in current electricity, right? Okay, that is
Yes,
a
yes.
very simple concept. Let's suppose if you consider your daily life situation, right? If you are driving a car, so your tire also face opposite force by the road, right? Because
Friction.
tire tries to move in forward direction and
Yes.
road tries to apply force in opposite direction, right?
Oh, so friction with the other
That
one.
is friction, right?
Oh,
So same goes for the charges. When charges are going to move through the conductor, so conductor is also a matter, right? It also
yes.
contain atoms. So when charges are going to move in a specific direction, so basically atom tries to resist their path, right?
Yeah.
Just like the friction in our daily life. Okay.
Oh,
Any confusion in that?
no.
Okay. Okay. Basically, there are two terms I'm going to define in two different concepts. One definition is related to we can say that in the definition form. One statement I'm going to write in the definition form, and second statement is in conceptual form, right? And if
Yes.
suppose they ask in exam, so you need to write in the definition form, right? Because we are going to
Yes,
define
yes.
in physical quantities, right? Electrical quantities. So first I'm going to write in the physical definition form. So the first one is basically resistance is a ratio between, it is a ratio between potential difference and electric current, right?
Yes.
So this is a specific definition. And the second one is a conceptual base, right? I'm writing with different colors, so that is conceptual base. Okay, so over here, so that will not confuse you in the definition. So if you want to write resistance in journal, so basically resistance is a hidden in of, right?
Yes.
When charges are going to move in forward direction or in any specific direction, so basically conductor or any material tries to resist those charges. That's why wires got heat up after some time, because resistance is always there, because nothing is 100% efficient, right?
Yes.
So that is a conceptual based statement. And by the definition, we may simply write the formula like this: R is the symbol for resistance, and for potential difference we used to write V, and for
Yeah.
electric current we used to write I, right?
Okay.
So this R is for resistance and V is for potential difference. Voltage in journal if you want to write. Okay. In definition potential difference, because we are going to discuss about whole circuit, not only battery. And I for
Oh,
electric current. And you already got the symbol for that. If you want to write the SI unit, so what will be the SI unit? Basically, there is a law related to resistance. We will also going to discuss after this one. So that law is on the name of the scientist, that is known as Ohm's law, OHM, right? So
okay.
basically, when some scientists give some law, so the quantity that he going to explain in his law, so SI unit will be same on that scientist name. So the symbol for, or the SI unit for the resistance is ohms, and the symbol for resistance is like omega. You observe this symbol on omega paints also. If sometime you observe omega colors, there is a brand name omega.
Oh, so this is the sign is omega, but it's ohms.
Yes, so basically this is a
Oh,
Greek symbol, omega. The name of the symbol is omega, but right, but we are not going to write omega, we only use the term ohms. This symbol gives you the SI unit of resistance, that is ohms, right?
okay. Yes.
But the Greek name of this symbol is omega. Okay.
Okay.
Okay, so this is the concept of resistance. And furthermore, if we want to talk about the resistance, so there are some factors also, right?
Yes.
Okay, if you need, so I will also draw a diagram to explain you how charges are going to be resist, or is it fine?
Yes, science.
Okay, because that is also simple like our daily life, right?
Yes.
So the important thing in this concept of resistance is the factors affecting resistor or resistance. That how many factors are there that will affect, it means that will increase or decrease the resistance. So factor affecting the resistance, now we need to discuss those factor. And this is an important topic, because there is also another formula we are going to discuss about, and that will help you to solve the questions also. So if we talk about the very first factor, so the first factor is very much simple, and the first factor is, right? First, I will give you a very simple example. Let's suppose if you observe a power bank, right, to charge your phone or anything. So mostly you observe that the length of the power bank or the charging cable is very much small as compared to the
Yes.
normal charging cable, right?
Yes.
So what is the reason?
That
Basically,
being
when,
faster.
yes, and how it is going to be charged fast, because in our daily life we use charger, and we used to plug in that charger into AC supply, right? Remember that difference between AC and DC? AC has unlimited charges, right? Because a transformer is going to transfer electricity and we are getting charges, so there is unlimited supply, so we are using lengthy cables. But in power bank there is a battery, so it means we are getting DC current, direct current, limited charges. Those are automatically, oh sorry, those are installed or those are stored in your battery, so you have limited number of charges, right? And you need to use those charges very efficiently, so that's why we use a small cable to connect phone and to connect power bank. So that is the reason, that is a factor of length. So it means that if you increase the length, so that will increase the resistance, right? Because charges
Yes.
have to move a long path and it will take time, and it will
Yes.
also find very much hindrance as compared to the original state. Okay, so we may write it as resistance will increase, resistance will increase with increase of length.
Then.
It means both are directly proportional. If we increase the length, so resistance will automatically increase. And it will be like this. R is directly proportional to length. Okay.
Uh, uh,
And the second factor is related to cross-sectional area. Area, cross-sectional area. And the meaning of cross-sectional area?
your voice is lagging a lot. No.
Just a minute. Okay, now is it clear?
Yes. Yes.
Okay. Okay, so actually for last 3 days, Zoom is having some glitch because of new update in it.
Yes. Yes.
Okay, so basically cross-sectional area is something different from area. Cross-sectional area means, let's suppose if you take example of your pencil or your pen, or let's suppose if we consider a marker. So let's suppose if we observe marker from the back side, right? From the
Yes.
refilling, where we have to refill ink in the marker. So if we observe from that side, or if we want to observe from the tip of the marker, right? So that part give you
Yes.
the
Yes.
concept of cross-sectional area. It will be like this. If we consider a wire from the front or back side, so the thickness of that wire basically gives you the concept of cross-sectional area, right? Just
Yes.
like the
Yes.
pipe, if we consider the hole in the pipe, so that hole in the pipe gives you the concept of cross-sectional area, because that will give you the concept that how much water is going to be flow through that specific pipe. Just like the gas pipe, water pipes, right? Those are connected with
Yes.
motor and gas supplies, or in cylinders, right?
Uh,
So same goes with the wire, because we are using different thickness of wires in different devices. So each wire has its own thickness, and thickness increase and decrease with the load of charges, right? So if we increase the cross-sectional area, let's suppose if you consider example of your classroom door and your
yes.
main gate of your school, right? So you know that
Yeah.
in from your classroom door, at a time only 2% can pass easily, right? Because the
Yes.
cross
Yes.
sectional area of that door is not much larger as compared to some other thing. And if we compare that door with the main gate of your school, so that gate has greater area as compared to the classroom door, right? So let's suppose if two
Yes.
students are going to pass that classroom door, so from the main gate of door there are multiple students, those can easily pass that door, like it may be 30, it may be 50, depending upon the size of the main gate, right? So it means
Yes.
that if we increase the area, so that will allow charges to pass easily, right? And if we decrease the area, So it will not allow charges to pass easily. So it means it is inversely proportional. If we increase one quantity, second quantity will automatically decrease. And if we increase second quantity, the first quantity will automatically decrease, right?
Yes.
So it will be reverse of the first statement, that resistance will decrease. So one quantity is decreasing. It means second quantity is increasing. Sorry, cross-sectional area. Sectional area, right?
Yes, yes.
Okay. So basically, if you want to write in form of equation, so it will be R is inversely to A, like this, right?
Yes.
Okay. Let's suppose we are also having different type of conductor like copper, iron, silver. So if we are using different material, so material of the wire remains same for that specific time or for that specific device, right? Let's suppose if we are using copper, so the material of copper remains same throughout the experiment because we are using copper wire, right? So basically there is a third factor that I will explain you in the formula. When we combine these equations, so this equation will be R is directly proportional to L upon A. Okay.
What does that mean?
And if we remove this proportionality sign, so your final formula will be equal to R is equals to rho. This P is in inclined form. So that is a different symbol which is known as rho. So R is equals to rho L upon A. Okay. So this is your final conclusion of these affecting resistance, right? And I will explain you the concept of this rho symbol. Basically, this is a symbol for resistivity.
What?
Resistivity. It's just like, let's suppose if we are having a bottle and a tub and a gallon, right? So the purpose of tub, bottle and gallon all are same. We need to store water in it, right? We
Yes.
store water in gallons also, we store water in tanks also, we store water in bottles also, right? Only the difference is of the capacity. The capacity of bottle is very much less as compared to the tank, right? Getting my point?
Yes.
And if we consider a tank, so the capacity of a tank is greater than water gallon, right?
Yes. Yes.
So that is same goes for resistivity.
So
Resistivity
how
means
how
that,
it is to
yes, resistivity means that for a specific material, let's suppose we use two word in our daily life that which one is good conductor, which one is bad conductor, right? Let's suppose we consider copper as a best conductor, right?
yeah.
In our daily life, because we know diamond is also a very good conductor as compared to copper, but normally we are not going to use diamond in our daily life, right?
Yes.
And we also use gold in microprocessor of your computers, right? So basically it depends upon the material. Resistivity is the capacity or ability to resist charges, right? In short,
Yes.
resistivity basically it is a capability of the material to uh, or it is, we can say that amount of resistance that is going to be provided by a specific material. So resistivity is a quantity
So
which
different
gives you the
materials have
concept.
different resistivity.
Yes.
So different materials like of copper, steel, like those ones, they have different resistivity.
Yes, basically resistivity is just like a specific property of material which will remain same. if we are using copper, so we know that copper is a good conductor. So resistance provided by the copper is less. And if we are talking about their capability or ability to stop charges
Yeah.
or to pass charges is greater, right?
Yes.
Or it is better to write property of a material
Yeah.
to test charge, right? And normally it will remains constant because once we connect a copper wire in the circuit, so it will always remains copper until we change the wire, right? So this is a constant type factor, right? Most of the time it will remain constant. Okay.
Yeah.
Okay, so basically this is the concept, and we are having another formula, R is equals to rho L upon A. Okay, let's suppose before solving the numerical questions, let's suppose if we are having a conceptual question like this. Question is, let's suppose if we increase the length of a wire, if we increase length of a wire,
Okay.
uh, times, right? And we are going to decrease cross-sectional area by 2 times. What will be the change in resistance, right? So you need to answer that.
Okay.
We are only having the concept of how much time we are going to increase length, how much time we are going to increase cross-sectional area. You need to answer in form of resistance. What will be the change in the total resistance, right? Getting my point?
Can you repeat it?
We need to use this formula. I will explain you first concept, then you may solve remaining by yourself, right? Because there is no numerical value, and in most of MCQs they used to draw a diagram. I will also show you in the paper that how questions are going to be. So let's suppose for this concept, because you need to answer in MCQ, so you don't need to show your working, because that was your rough working, and
Yes.
most of these type of questions are going to be asked in your MCQs. Okay, so we need to use the same formula, R is equals to rho L upon A. Now ignore this resistivity term, right? Because if we are using a copper, so it will remain copper, right? We just increase the length of that copper wire. Okay. So we need
Yes.
to solve this question like this. Just consider L over A. Ignore this quantity. It will remain constant throughout the experiment. Because if we change this value, so we need to write the specific value for that, right? Yes.
Okay.
So basically, we actually increase this length by 2 times. So 2 times the length, and area is going to be decreased by, sorry, it is 3 times written in the question. Area is going to be decreased by 2 times. When you are going to decrease, so it will be 1 over 2, right?
Yes.
Okay. And if you have good mathematics concept and you can easily shuffle the equation, so that will be not a difficult part to flip
So,
this
so where
equation.
does the P go?
Yes.
Like the
Basically,
that.
this is a constant factor, right? And you don't need to answer in number. Your answer will be in that resistance will increase 2 times, resistance will decrease 3 times, like this. Because it will remain constant now. If the value of this resistivity is 10, so it will also multiply with the final result of second situation, right?
Yeah.
So that's why we are not going to include this term in this type of question. If we are having fixed values, all values are given in numbers, so then we are going to include this one. Otherwise, this is a very simple way to solve these type of question, because you only need to answer resistance in like proportional way, that it is going to be decreased this time or increased by this time, right?
Oh, so the P sign
Yes.
is removed.
Yes. So that's why we ignore this sign for a time, because we know that it will remain same,
Yes.
right? So there is no effect of that specific value. So your final answer will be like R is equals to, now we need to flip this equation, and this equation will be 3 times 2 over 1, right? Because in
Yes.
denominator we are having 1 to 1 over 2, and we
Yes.
flip this equation, so it will be 2 over 1. And remove this L or A, because we are not going to calculate again the numbers, we are just need to answer in equation. Okay, one more thing, if we decrease the resistance, sorry, if we decrease the cross sectional area, so resistance will increase, right?
Yeah.
So it means by using this factor we are going to increase the resistance, and by using this factor we are going to decrease the resistance. So your final answer will be 6 times, right? Sure, your resistance will be 6 times as compared to the previous resistance. Okay.
Oh,
Let's suppose if there is resistance given in the question, let's suppose, so from that specific value your resistance will increase or decrease 6 times depending upon the initial value, right?
yes.
So you can easily solve these type of question, like if length will decrease, or let's suppose if another question is like this. These are just like conceptual question. So now if we decrease length this time,
Yeah.
it will decrease, and the cross sectional area, so it will cause time increase, right? So again we are going to same
Yeah.
use the same concept. R is equals to, for that raw symbol, because it will remain
Yes.
constant. So now resistance length is going to be decreased, so now we are going to use 1 over 4 in meter and 3 in, right? And again if you flip the
Also,
values,
the one which is decreasing will put it one over
yes,
at the number.
because decreasing
Okay.
means to inversely proportional like this, right? And
Okay.
increasing means directly proportional.
Okay.
Okay. So now
Okay.
when we are going to flip these values, just write 1 over here, because if nothing is written under any
Yeah.
number, so it will be 1. So that will be easy for you to flip the equation. So it will be 1 over 4 into
See.
1 over 3, right?
Yes. So one over
So,
ten.
yes, because we have 3 over 1 in denominator. So when we split numerator, so it will be 1 over 3. Answer will be 1 over 12 times. Okay.
Okay.
So basically your resistance is decreasing because 1 over 12 we are getting, right?
Yes.
So this is our final answer of this type of question. Okay. Any confusion?